I can hear you. Good night.
Okay, so I want to start recording. So you can start after I start recording. Okay, you started already. Awesome.
Okay,
Okay.
yeah.
So you can do the introduction
Okay.
again.
Okay. So once again, good evening, everyone. Good evening, good day, Mr. Bruno. Thank you for honoring our invitation. So please, can you just tell us one or two things about yourself?
Yeah, sure. Yes, I'm sorry. Should I start? Give me a thumbs up and I will start.
Yes, please, yes.
Perfect. So let me share my screen and let me know if you can see my screen. Should be fast. Let me close this, close that, and stop the camera and share the screen. There it is. So
Yes, we can. We can see your screen.
perfect. So hello everyone. Happy to be here. Happy to be part of this. My name is Bruno Capuano. I live in Canada. I am a Microsoft MVP. Probably notice the accent. I'm not Canadian. I was born in Argentina, live a couple of years later in Spain, moved to Canada 5 years ago, and I've been playing around with Microsoft technology for 20 years or more. I work in Avanade, I lead innovation, so I play around with a lot of new technologies. And today, I love this session because this is going back to doing some code with the .NET platform around machine learning. And what I am going to share with you today is machinelearning.net, which is a framework created for .NET developer to do machine learning. I start always, sorry about this, with a couple of warnings. Sorry about my bad jokes, the crappy demos and whatever. I know I'm not supposed to do this, but hey, this is the way that I do things. And as I mentioned, I've been a .NET developer for almost 20 years or more, since the early 2000s. And you can do a lot of stuff with .NET. Usually we use .NET for desktop and cloud, but you can also do gaming, you can also do IoT, and in the last years, we can also start to play around with machine learning, which is one of the key components, one of the hot topics that we can start to do. And it's great because, I mean, if you are going to do machine learning, for sure, you are probably going to think of going to TensorFlow and Python, or Coffee, or Keras, which are amazing tools to do machine learning. But if you are already some kind connected in the Microsoft world, machinelearning.net is a super fast way to start, to get the basic concept, to get a lot of information around machine learning. So I really think it's a great way to do this. And by the way, machine learning, it's free, it's open source. You don't need to, it's based on .NET Core, so you can run this on Windows, Linux, or Mac. And if you have any question, or you want to get deeper on how things work, you can go to the .NET. You can go to GitHub and see the source code, basically, but you can also go to .NET/ML and start to see the different set of scenarios. And machinelearning.net is a framework that Microsoft has been using internally for a long time. They released it to the public 3 years ago. 2 years ago, we have the first GA, the big one version, the official supported version, and it's growing. And personally, I like it because there is a repository. I am going to share all of the links later, but there is a repository where you can go and you can start to see what is there, how it's built, what we have. So, an example, let me show this. Let's copy this URL. Let's open Edge. Where is Edge? Oh, here in the other window. So let me go back here. So let me bring Edge to this window. If you go here, and this is what I like, this is the samples repository. you're going to start to browse the samples and you're going to start to figure out different type of scenarios. Like if you want to do binary classification or multi-class classification or recommendation or regressions or anomaly detection, or there are plenty of scenarios. And each one of these, in example, if we want to do the iris flower classification or issue classification, usually have samples in C# at least, and also C# and F#. And you go to the sample, you go to the specific sample, and you will have here, which is the version of machine learning.net that they are using, which is the status of the demo is up to date, the type of application, this is a console application, and a set of overview, how you are supposed to do this, how you prove, all of the information that you need to run this. So I think it's super cool to have this, to have all of this repository, because for me, an example, which I am not a data scientist expert, I am mostly an enthusiast. I come here, if I need to solve a problem, I pick up something that is around here, and this is good enough for me to start to have a sense of what can I do, how can I move forward. Because the ABC of machine learning, and again, I am not an expert, I am just an enthusiast of everything is happening here. Let me put myself a little smaller here. This is the ABC of machine learning. This is how we do machine learning. It's basically 3 steps. I know, expert going to kill me. It's much more complex, but we basically start with data. We need to solve the problem. To solve these problems, once we have the data, we select and we try with a couple of algorithms to solve this problem. With this algorithm, we create a model, what is called a model, which is basically a function. And then this function is going to receive an input, and we're going to have an output. And this is what we are going to use. So it's very simple if I explaining like this, but when we are here, this is where we start to spend some time, because the data is the part that we probably spend most of the time picking up the data, cleaning the data, trying to get accurate and real data to work with this. So once we have the data and the data is clean, we start to define the data. This is going to be features, this is going to be labels. So we need to work with the data. We spend probably 80 or 70% of the time with the data. Then is the fun part, which is play around with algorithm, tuning an algorithm, working with different set of parameters and values to see how we can get a model, and then we need to evaluate the model. The way that we do this is usually for the initial set of data that we have, we split the data 80-20 or 70-30 or something like this, and we use the bigger chunk, 70% in example, to train the data. And then when we have the data, we use the other 30 to evaluate. Okay, we generate a model, let's evaluate with this real data so we know if we have an accurate or a good model there. And then we have this, we're going to start to use the model. Remember, the model for us is basically most of the time, most of the scenario, there are plenty of different type of machine learning tasks that we can do, but most of the time is like a box. It's a function that will receive an input and it will give us an output. So we can do sentiment analysis, which is probably, this is the demo that I'm going to do today. And we can train the model to detect, is a text, a tweet, in example, is a mean tweet or not, or is a toxic tweet, or it's used, I don't know, bad words there. And what we are going to have as a response when we use this model, we're going to have a 0 or a 1, where we are going to say, okay, 1 is a toxic comment or 0 is not toxic. And we're also probably going to have something different, which is basically, I don't know if it is toxic or not. For me, it's 0.72. So we as developer, we as programmer, we need to figure out, okay, 72 is close to 1, so I am going to consider this toxic, or maybe no, I am only going to consider toxic 80 and above, or something like this. But this is kind of the idea. We train a model, we do sentiment, and we do kind of a box, it's going to have an input and an output. So I am a demo person. I want to show you how this works. So what I am going to do now, I am going to explain in a couple of slides how we can create this sentiment analysis process, and then I'm going to code so you can take a look how you can code this yourself. So I am going to use this data set. This data set is comments from Wikipedia. The Wikipedia team published a set of data sets around comments and contents, a lot of stuff, and they have huge data set with comments where we can filter them by year, by namespaces, which is kind of a category and this kind of stuff. And then we have also label, which is basically if the comment is toxic, true or false. So when someone writes bad stuff, it's going to have 1. A normal comment is going to have 0. So for us, we are not going to use all of the other columns. We are going to use one of these 2, the comments and the toxic. The comments is going to be our features. This is what we are going to use for train the model. And then we are going to use the label. We're going to use the toxic column as the label. This is what we want to predict, if this comment is going to be a toxic one. The way that we do this, this is in the machine learning world, this is a binary classification because we are going to do A or B. There are different type of tasks that we can do, but this is one of the simple one. And again, you can take a look at the others in the main repo, so you can see how this work. So first step, data. Oh my God, the slides are not working well here. But first step, data. As I mentioned, we are going to use these data sets. We have all of these columns, and we know that we are going to have features and label. Then there is a specific task that we need to do here because the label is a number, and we are basically working with numeric and arithmetic algorithms. So we need to transform every string, in example, to numbers. So, and again, there are ways that you can do this automatically. I am explaining this here so you can get a deeper understanding of what we do. But the idea here is that we are going to pick up this column, the text column, the comment column, which is a string, and we are going to apply a featureizer, a text featureizer, to transform these to numbers. This is going to create a vector of numbers related to each one of the words and the letters, so we can work with them later. Because again, what we have here is we are working with algorithms. Then when we have this, we are going to build, we are going to create the model. This is the fun part. Let's pick up an algorithm. We have different type of algorithms. I am going to show you a couple today. And then we are going to create the model. And the model, as I mentioned, is the black box, is the function that we can use later. We can use the model to start to do predictions. So we can use a new single row, a new comment, rude, dude, whatever, bad words or whatever, and it's going to do some prediction. And we are going to have, yes, this text that you are input here is toxic or is not toxic. So this is a super simple way to explain what we can do. But let's code this. Let's do this. I am a big fan of coding, so let's write this from the scratch. So in order to do this, what I am going to do, I have here my Visual Studio. I am going to create a new console application. By the way, I am using here Visual Studio 2022. This is a preview version. This is kind of not a very stable one. I am using also the preview net6 version here, but I am going to create a console application. You can do the same in Visual Studio 2017, 2019, or even Visual Studio Code. But the basic idea here is that I create an empty console application, and I am going to add a couple of packages. This is the same, if you know Python, that do pip install. So I am going to install a couple of packages, or if you're using Node and you want to install with NPM, so this is the way that we are going to install a new package for C#. So I'm going to go here. I like this because it's a visual interface. I am going to search for Microsoft.ml. When I search for Microsoft.ml, I have a lot of libraries here which are developed and shared by the Microsoft teams. You can also contribute here, and you see that we have the standard one. This is the Microsoft.ml, but then I have specific ones to work with mathematical operation in the CPU, other for do some data visualization, other for interaction with the Onyx runtime. Plenty of things that we can do. I am just going to do basic machine learning, so the one that basic is good enough for me, and I installed this. So now it's installed, it's part of my project. I can start to work and I can start to do things. So the data that I'm going to use, let me go here, is I told you that I have this huge data file. Let me show you the file. This huge data file, where's this one? So this is the data that I'm going to use. So as you see here, it has 40,000 rows. So I don't have Summit, sorry, let me open Summit. So we have, Summit. We have 40,000 rows there, which is kind of a lot. It's a 17 megabyte file, and the files that we have here, the columns that we have the label, we want to use the label. We have a revision ID, we don't need the revision. The comment, this is what we are using, and then we need other ones like, we don't need other ones like the year, who logged the comment, the namespace, sample, or whatever. And this is the file that we are going to use. So I am going to add this file into Visual Studio, into my project, so we can use this later. Let me add existing item, go to my sample projects, data samples, sentiment analysis, all files, there it is. I am going to add these two because I am going to show you later what we can do. So add as link, and now I have both here in my project. So the first step here, now that I have this up and running in my project, is let's start to do some code. So there are several ways that I can interact with the data using machine learning, but for this demo, what I am going to do, I am going to create, sorry. What's happened with my keyboard? It's not working anymore. There it is, sorry. Something happened with my keyboard. Let's see. No, it's not working. Let's close Visual Studio and open it again. This is what's happening when you play with betas, no problem. I have the demo also already complete, but let's give this one more try. Okay, here we are. Now the keyword is back. So what I am going to do here, I am going to create two classes. This is very simple. If you read Java, JavaScript, C++, you are going to understand this. And I'm going to have a first class to understand the elements that I have here in my big file, which is going to have a label as a Boolean and a text as the comment, and then I'm going to have a prediction. And also here, I am going to define that the label is going to be the first column, the zero index column, and the comment is going to be the number 2. So that's basically it. That's how I define my classes to start to work, and then I can start to do the machine learning. The first thing that I'm going to do, I am going to create Yes, I'm sorry, there is a question. Oh, no, just background noise, I'm sorry. So the first thing that I'm going to do, I am going to create a context, because in order to work with machine learning, we need to have a context that we need to use. This is kind of a chain where we are going to define the steps. First step is going to be load the data, do this stuff with the data, train a model, and give me the model. So this is what we use as a context, and this is what the first step that I need to use. Then I'm going to load the data. Remember that this is I am using a local file. This is my wiki detox file. So I have here load the data. I am going to load the data from this tab separated values file. I can define here that has a header. I have other ways to do here, like an example, use this as a separator for the elements, and it has quoting or not. I can do plenty of stuff. And by the way, I am loading data here from a local file, from this file, but I can load information from a SQL Server database or from a different set of data sources. So there are plenty of ways that you can do this. Remember that I told you that I'm going to split the data, that I'm going to use one set of data to train the model and another to evaluate. So this is what I'm going to do here. I am going to use the context. I am going to say, hey, context, train this data. Give me a 80-20% split of the data, and I am going to have two data sets, training data and test data, to work with them. So now that I have the data, what I need to start to do here, I need to start with my pipeline. I need to start to create the process, the step that I need to do. So the first thing that I'm going to do is, because I know that one of the columns is a text column, I will pick up this column, the comment column, the text column, and I am going to say, I am going to use featureize. I am going to say, hey, pick up this text column and featureize this into numbers so we can train the model. And then we head to the fun part, which is, let's train the algorithms. Let's create a model. So I can go here. Let me put this on the top so everybody can see. And we are going to do binary classification. So I am going to say machine learning context, give me binary classification. I can pick up for a set of different type of trainers. So you see here I have the average perception, the field-aware factorization machine, LB, FGS, a linear SVM. There are plenty of different type of models that, algorithms that I can use to train. I'm going to use SDCA, but I am going to show you later how you can choose the better one, how you can choose, because if you don't know which one of the algorithms, there is no easy way to find which is the best for your scenario, but I'm going to show you how you can get closer to the best one. And for this one, for the SDCA, so the stochastic dual coordinator ascent logic regression, I am going to define also that my columns will be labeled and future. So I have here my trainer. And then I can start to basically train the model. Let me train the model, and which is super simple. And also let's evaluate the model. Remember that once I have my model trained, I want to see how well my model is working. I am going to use for this the test data. So I have trained my model with the initial set of data. Now I am going to evaluate the model to see how well my model is working. And then this is going to be fast. So let me copy here this. I am going to create and start to use my model. I'm going to do some predictions here. So I have here the predictions, and let me add my prediction function here. So let's review quickly this. I am going to create the prediction engines. I have my model trained, which is kind of amazing. This is the trained model that I have. And then I'm going to start to do some prediction with this text. And I am using general text. I love this movie. This movie is stupid. The vacuum that I got from Best Buy is amazing. The vacuum sucks so much dirt. And then I'm going to finish. And basically, this predict function is going to pick up the model and is going to analyze this. And it's going to show me a couple of things. So let me run this step by step. Let's see if I didn't forget anything. Start this as startup model. There it is, build, and let's debug this. This should be kind of fast. This file is not very big, but we are going to load the data, split the data, featureize the comment column in string to numbers, and then we are going to train our model. This is train our model, This is the part that my machine is going to work. My machine is going to do kind of in a couple of, at least a minute, I think. We are going to use, is going to train the model. You can see here in the diagnostics tool how I am using more and more RAM. I am around 500 or 600 megabytes of RAM. It's basically what we are using. Then I have my model trained, and I can evaluate my model. I can see how well my model works. So I have these metric numbers where I can see, I need to, come on, okay. Here it is. I have my metrics number here where I can see in example that once I train my model, I have an accuracy, which is kind of a nice number to watch here in this type of models, of a 94% here, which is super decent. It's a good number to understand. And this, I'm sorry, this goes from 0 to 1, so 0.94 is 94% of accuracy, which is super one. But I can also take a look here at the F1 score, the log loss, the negative recall, the positive recall. There are other values here that I can analyze. But this model so far is kind of good in 95%. So my next step will be, hey, you know what? Give me an engine and start to do some prediction. So I'm going to do a prediction with engine about this test. How do I do a prediction? So I create a new element, the test sentiment, which is going to have this, I love this movie text, and then I am going to do a prediction. The prediction is an array of numbers. So this is not going to be toxic. Let me pin this. Oh, there it is. So this is not going to, let's do this in bigger way. So this is not going to be toxic because it's toxic false, and it has a lower score, 0.009. So it's not toxic. So that's good. And I'm going to draw this, show this in the console. In the next one, this movie is stupid. I do the same. Here I have a prediction. The prediction is bigger here. Is a toxic comment. I have 0.95, so 95% of prediction to be true, so that's why I consider. And I can run this until the end. And if I go back here to my console, you can take a look that I love this movie. It's fine. This movie is stupid. It's considered toxic. The vacuum that I got from Best Buy is amazing. And the last one is the vacuum sucks so much dirt is considered toxic because sucks so much is bad in English, but in a vacuum scenario, this is important. So I will probably need to go back here and change my initial data set, the one that I am using. I am use another one that I add some comments to have a better understanding of a vacuum scenario. There it is. And at any moment here, I will have my model trained, and I can start to do, again, the same analysis with the same sentence, but I am going to see that in this one, the last comment is good. The last comment is not considered toxic. So, hey, I have a decent model. But the idea here is if I want to use this model again and again, I am not expected to train this and again and again. At any moment, what I need to do, what I can do is, once I have my model and I am happy with the model, I can save the model. Let me show you these lines that are very important. I can save the model. So I can go here and say, hey, machine learning, save this model. I can save this model.zip or whatever I want to do, so I can load the next time and reuse it later. And this will be super, super helpful for me if I want to reuse this again and again and again, because as I mentioned, you don't need to train this. You can reuse it, and the next time, instead of train the model, you can do ml context.model.load, and then you put here the path of the model, and that's it. You can load the model and you can start using it. So in less than 100 lines of code, we created a model to do sentiment analysis, and it's kind of fine. It's kind of great. It's super easy to do. And let me show you, before going to AutoML, another scenario that you can do here, which is kind of different. In this one, we are not going to train a model to do stuff, but we are going to analyze chunks of data to detect anomalies. And the way that we detect anomalies is basically, we have a timeline. Oh, thanks for the compliments in the comments. We have a timeline here, and a timeline of a data series, timeline with data, and we are going to analyze this data, and we are going to try to detect anomalies there in the timeline. So let me show you the ABC of how we can do this. So I am going to go back here, and I am going to use, I think everybody understands this, so I am going to use Excel. I have here a CSV. I have here a set of values that are a time series with dates in months. I have dates from January to February to March, and I don't have value for all the dates, and I have product sales. I don't know. think about sales, revenue for months or something like this, and I have 36 elements. So let's create a chart with this, super fast. And let's take a look here at this chart. So if you ask me as a human what I think about this and where are anomalies, I will probably say that, let me change color here. Options, draw, light zoom, type. Why I can't change my colors? It's not working. Then let me do this one more time. Okay. So let's do this again and Control G. There it is. So I can define, if I read this as a human, somehow my keyboard is not working today. I can probably create a pattern here and define that, hey, you know what, if I see this, I will probably look for something like this, where this is my good value. I can understand, again, as a human, I am not very smart, but I can understand that this is kind of a pattern where the data is flowing. And this one, maybe this one, and maybe this one, and maybe this one, and everything that is outside of this pattern can be considered an anomaly. So I can read this data, I can do this estimation, and it's probably going to be fine. But there are some moments that we as humans cannot do this. They are tricky for us. So if I show you if I show you this picture, there is something wrong in this picture. Sorry about that, big Star Wars fans here. If you already knows what is wrong with this picture, let me know. But at the first look, what is wrong here? Can you take a look and pick? Can you take a guess? Feel free to write it. I am going to share it later. But there is something that is not supposed to be here. So this is I will share this image with you for 20 seconds while I drink some water. Okay, let me show you the problem here. The problem here is we have a panda. There is a lot of stormtrooper here, but there is a panda there. But because we have all in black and white, or with with similar drawing styles, it's super hard for us as humans to understand this. So this is where machine learning.net can help us to do stuff like anomaly detection, because with very, very few lines of code, where is my anomaly detection? We can write, let me show you how we can do anomaly detection. So let's create a new project, console application, 03, net preview, create. There it is. I am going to do everything that I've already done. That this is going to go to NuGet, add my machine learning package, and for this one I am going to use also machine learning time series, because this is the one that we use also in machine learning. So I have the two installed, and what I am going to write right now, I am going to add the sales file that I show you in Excel. So existing item, let's go for data samples, anomaly detection, product sales CSV, there it is, add as link, copy to output directory. And once I have this, let me show you how we do anomaly detection, how we can do the same stuff I already did there. So let me do some cleanup very fast here. Once we have the cleanup, let's add the reference. I'm sorry, I'm a fast Visual Studio user. And oh my God, I forgot to add the classes. 16 items. I need to add these two classes also. So this is how we do anomaly detection. First of all, we do, remember this is ABC, we load the data, we load our product CSV file. This is the one that we are going to use, so this is what we need to keep in mind. Then we create an estimator. Remember, first step, load data, then create a prediction model, create a model, and then do predictions here. But the difference here is that we are going to pick up, we are going to use these algorithms here, which is the detect IID spike. And then this algorithm requires a couple of values here. First of all is which is the output column that we want to do the prediction, the name of the input column, which is going to be the numeric cells, the confidence. Remember that I draw a line, so every point outside of this area is going to be considered an anomaly. And because we are going to analyze the information in spikes, in chunks, this is what we are going to have. We have here 36 rows that we have in the data set, and we are going to use every nine elements to do some historical analysis. And then we are going to do the analysis. And what I am doing here in the bottom is basically, if we have a prediction, I'm going to change the color and show the values there. So if we run this, what I forgot, product sales data. Oh. Product sales. Sorry, I forget to add the generic. Let's run this again. And it's going to be super fast. And I have here some values. So let's take a look at the values and the Excel. So the first value that is considered anomaly is 341, which is this one. So it makes sense to use this as an anomaly because we have this, remember in the chart of what we have. The second is 426, which is this one. And then I have 580 and 687, which is probably this one and this one. So right now, my algorithm detects this one, and these two as an anomalies. If I go back to my code and I change, in example, the confidence lower, so everything bigger than 80% will be considered an anomaly, I will have much more values here. So probably here right now, I'm not going to do everything. It's going to be so slow, but hey, we are going to have a lot of values here that are going to be considered anomalies. But you make I hope you understand how using 50 lines of code, I can pick up a data series or a series of data. In this case is numeric data in time, and I can quickly go and start to find anomalies there. And I can use different type of algorithms to do this, detect spikes. Then I have also detect anomaly by SRCNN, the point by SSA. So there are different type of anomalies that I can play around to start to do this. But this brings us to the last part of the session, which is basically, we try to do this, we try to do machine learning, we try to do these kind of things. This is the happy world of machine learning, where you type your code, you have your data, you want to do this, you're expecting an amazing unicorn, super happy, super amazing, but this is what you have. Because choosing the right algorithms, choosing the right values, it's super complicated. It's super hard. That's why we are lucky that we have in our tools this new set of tools in machinelearning.net, AutoML in Model Builder, which basically allows us to avoid this mess, which is playing around with the scenarios, which is a good way to explain this. So when I started to do AutoML and I started to explain, I started to use a scenario where, hey, what if I need to create a model to do predictions around taxi fares, Uber fares? I have a huge data set with a lot of values around date and time, numbers of passengers, time of a trip, I don't know, destinations and fare, and I want to make predictions how much a taxi trip is going to cost from point A to B. So I have some features: distance, trip time, car type, passengers, time of day, and more features. Then I have different type of algorithms: gradient boosted, nearest neighbor, SGD. Each one of these algorithms has some parameters. So if I want to train a model, I can pick up some features, some columns that I have here, pick up one of the algorithms with a specific set of parameters, train my algorithms, and when I evaluate my algorithms, this is 30% good algorithms, which is kind of nice. Okay, so I will try with something else because 30% is small. I make some changes, test a new one. Hey, this is better, 50%, still not good enough. So I start to play around. And when we do machine learning, we do a lot of this. Testing, new algorithm, new parameters, same algorithm, different parameters. We test A, B, C, A, C, B. And at the end, we do a lot of stuff and we spend a lot of time doing these kind of things. But this is when machine learning and AutoML help us to do this. Because we have a tool right now that can help us to do this scenario. We're going to have data. We're going to define what we want to do, some constraints, and then AutoML is going to test, is going to perform all of this type of different set of tests, and it's going to give us, hey, I did a lot of tests, and this is the best model. And it's also going to explain us, we're going to have some kind of explainability in the models that, hey, in this model that has 95% of accuracy, in example, this is the importance of the columns that you have. And this other model, which has 70%, this is the importance of the column that you have. So maybe for us, the trip time is the most important column, the most important feature. We probably need to go to the second module and start there to have a better model. And this is so easy to do. So I am going to go back. Let me close everything here. I am going to go back to the sentiment analysis. And remember that in the sentiment analysis, I use this SCD, SDCA logistic regression algorithm. Let's see if this is the best one to do this. So what I am going to do here in this project, I am going to add a new element, machine learning element. Once I add the machine learning element, this is one element that we have available here. I have some kind of scenarios to work here. So I have here the chance to do some, let me close this. I don't want to save. So I am going to do test classification because I have my test. For this type of scenario, I only have the chance to run this locally. If I choose other scenario like image classification, I can use Azure to do this. So I can create a workspace and do the training on the cloud. For this one, which is text, I am going to use my local scenario, the GPU. So my next step is, okay, where is the file? What I need to do? My file is in sentiment analysis, Wikidetox, Wikipedia, there it is, open. And then I will have here a lot of information to start to play around. So which is the column that I want to predict, the label column, and let's figure out which other columns that I have. So revision ID, I don't need it. The comment is my feature. Year, I don't need it. Logit, I don't need it. Namespace, don't need it. Sample, don't need it. Split, don't need it. And because don't need it, this is not categorical. But here, it automatically detects the type of values here. So it's going to be a single, comment is going to be string, booleans. So I have here, and I can even say that, hey, this has a header with column names, separators is set up. So I have everything here. Once I have this, I can start to train my model. We don't have a lot of time, so I am going to put this to training in 2 minutes. Because the file is big, it's going to suggest me to do this with a bigger time, but it's going to spend 120 seconds for training this. Of course, here, if you put more time, this is more chances that you are going to find different combinations, different type of algorithms and parameters to get the better model. But right now, with 2 minutes, I hope it's good enough to at least show me 2 different type of combinations that I can start to use. So the first an example here is already test 1, which is the one that probably I am using, SDCA, and we have here the accuracy that we have here is around 89%, which is kind of good. So let's wait to see if in the next minute it tests at least 2. But I hope that you get an idea that right now what this AutoML is doing is training the model so I can avoid playing around with model, with text and code, and this is going to test a couple of models and give me the best one. And said, okay, I spent 10 minutes, 2 hours, a full night, a couple of days doing this, and the best model that I found is this one. By the way, my CPU right now, it's working hard because it's doing everything locally. So this is the moment that you need to go and have some coffee or do something else, because this is you're really using your CPU. This is not using GPU for this specific one. There are others that you can use the GPU for, not for this one, but still training. We have a second one here, Forest OBA, which is a little better, much more better. I mean, 94%. So right now, if we stop the training here, this is going to be the suggested one, but you get the idea. It's training different models, and this is the output. This is what I have at the end. It tested 2 algorithms, 2 ways to generate a model. It gave me a full time of the experiment. It's running this. Then I have the top 2. If I put more time, I will probably have 3, 4, 5, 10, or 20, depending on the time. But it's going to give me also the best one. And the good part, what I really like here, is that once it's here, once we have the best model, the one that we can use, we can start to do predictions here. So remember, this movie is great. I can predict this. And okay, this is not a toxic comment because I have 95% of 0. So this movie is stupid. Make a prediction. This is going to be a toxic comment, 1%. And if I go, let me pick up here my text. Let me copy the vacuum that I got from Best Buy. It's amazing. I do a prediction. This is going to be a good one, 95% of 0, so it's not toxic. But if I go the vacuum so much there, I use, remember, the first data set here. So if I do the prediction here, I have that this is a toxic comment. So the next step here will be, okay, this is the way that you can consume. It's super cool. Here you can generate a console application where you are going to have all of the sample code that you need to run this, to run and use this model. Or even if you want to use this in a web API, you're going to have here a web API application in your solution that you can deploy, an example to Azure, and use as a function to run with your model. An example here, this is the web API. The API will have somewhere here. The product handler, we have the product handler, and we have the predict engine. Yes? There is a question or?
Okay, so if I think Osnachi's network is a little bit bad. So I'll just for him. So please, if there are any questions, please you can just signify by raising your hand.
Yes, I see that we have here. Samsung has a question.
Okay. I think Samsung.
Thank you for awesome question. I really enjoyed it. I have a question. Just like in Python, they have actually common tool that they use for manipulating data in either shared view or shared view. Just like pandas and match. So which tool is used for like manipulating data, like cleaning data and getting it ready for sharing?
I'm so sorry. I probably have some bad internet or something. I hear you very, very robotic. I couldn't understand. If you want to write the question in the chat, if it's not very big, I will be happy to pick up from there.
Okay. Can you hear me now?
Let's give it a try if you want. Let's give it a try again, but it's good a lot.
Can you hear me now?
Oh, that's much more better. Yes.
Okay, sorry for that. I'm asking, just like in Python, they have tools like matplotlib and pandas that's used for cleaning data and manipulating data before you train it. In .NET, or C# in ML.NET, like which tool is used for cleaning data and getting it ready for training?
That's a great question. So in .NET, what we have, the tools to work with data are not specific to machine learning.net, but what we have here is tools like LinkQ. LinkQ is a great tool that allows us to do a lot of queries using code to do, it's not pandas, but has a lot of stuff that you can do here with pandas. What we don't have right now as useful in .NET that is in Python world is something like NumPy, NumPy, which is super cool to work with arrays and tables. There are other tools other packages and other frameworks that you can use for there. I will be happy. I don't have any sample to show with that stuff, but I will be happy to share if you want some links later around similar tools. Something like, hey, for pandas in the .NET world, you can use LinkQ plus ABC to have similar experience. For NumPy in the .NET world, you can do CD for this. But that's a great question because yes, training the model is super amazing, but to get the data is where we spend a lot of time. So hey, I appreciate that you remind me to make some aclarations, to make some points here.
Okay, thank you very much, sir.
You're welcome. No, by the way, I'm done. I'm close to the end. So the only last thing that I want to show you, not here, is that if we want to do something similar to this, but with image, if we want to do an image recognition scenario, we can use the cloud, so we can do image recognition, go for Azure. We need to have an Azure account, of course. You probably all need this, that you have an Azure account. When you have an Azure account, this is a next wizard, but you define this. And if you choose to do some training, in example, I have my workspace in the cloud to train images. And I have here a super simple set of images, of drawings in folders, fish, flower, and humans. So it's going to pick up the image that are in each one of the folders and generate this. And if I start the training, this is going to upload the images to the cloud and it's going to do the training in the cloud. So I can take a look and start to, if you don't have resources locally to do this, you can also use cloud resources to do this. So let me copy this.
I have a question. Yeah. So what is the cost for training models on Azure?
That's a good one. And here in example for this one, here it's using Azure Machine Learning and it's using a compute. And what I have here created is this machine learning. It's kind of a virtual machine to train, and it's an NSC6. And as far as I remember, the NX6, I think it's almost $1 an hour. So you can create this. This will have 6 cores, 56 gigabytes of RAM, and 300 gigabytes of disk with an NVIDIA Tesla K8. But if you want to have cheaper machines, you can pick up this one, like they start in 11 cents an hour. So if you have as a Microsoft student, I think the students you have some kind of budget. I can't remember. I probably need to go back to Pablo to ask, but you can pick up this one and use them. And hey, it's not going to be as fast as the other one, but you can have here running models, training model for a long time. And the super cool thing is that once you stop using this, you can get here, delete it, and hey, that's it. You don't need to use it anymore. Right now it's running. Stop of news stuff. Let me go to my work. So it's running this email classification experiment, which is running here. It will take 15 minutes or so. Let me go back to the first one. 6 minutes to train this, and similar, because it's AutoML, similar to the other, is going to test a couple of models, and in this case, the best model is Ceres, and you can download the model, and you can use a model PT, which is a TensorFlow one. But hey, you can play around. My main idea here to show you is that you can do this all from Visual Studio without leaving Visual Studio, and at the end, you are going to have something similar like this, where you can consume and do this directly from Visual Studio. So we are getting close to the end. I am going to share the slides and the codes later today. This is the main links that you can start. So let me copy and paste this here because this is the official one. And hey, every other question, everything else, feel free to contact me. I will be happy to help and respond. The fastest way to contact me is probably via Twitter. So you have my email. I read my email, but I am not as fast with email as I suppose. I'm sorry about that. But in Twitter, I will probably respond faster. Thank you very much for the applause. And hey, it's been a pleasure. Maybe next time we can talk back. We can go back and talk about drones or very small. I have a new session around programming very small processors to detect images and flying sharks. And hey, I have a couple of other fun sessions that we can do later. But as usual, a pleasure to be here. I will be around for the next minute and a half, and I need to switch to something else. So if someone has a last-minute question, I will be happy to try to help.
Thank you very much, Bruno. Your session has been amazing. It's really amazing. I've learned a lot. I've discovered a lot. Thank you very much. It's really been awesome joining this call, being on this call with you. And on behalf of the Microsoft Student Ambassadors, Nigeria, we want to say thank you very much. You actually...
Yes, I am going to show you something. I'm listening.
Yeah, so you would actually be the first MVP who would actually be attending our AI series event 2 times. And there is also a possibility of the 3rd time. so it's really amazing. Thank you very much. Thank you so much for your support.
As a teaser for next time, this is the session that I've been talking about: TinyML and flying zombie sharks. I know it doesn't make sense, but it's a lot of fun. So hey, I will commit. Yes, I will commit to talk with you, I don't know, maybe next month or whatever in the near future, and talk about this. It's again a lot of Microsoft stuff, but I use small sharks as the excuse to have some fun and talk about machine learning.
Okay, awesome. So it's 5 on dot, and we'll be coming to the end of the program of the training today. Thank you very much, Bruno, once again. Thank you very much, Osinachi, our moderator. He has issues with the internet, so he had to drop off. Thank you very much, Israel, Samson, everybody that has joined this call. And we would call it a day. See you guys on our next series. Bye-bye.
Okay, goodbye.
Bye.
Goodbye, Bruno. Bye.